Hello children, welcome back to the digital class. I hope you are all doing well. So in our previous session, we learned about area of plane figures in part 1. Now in this session, we are going to continue the same in our part 2. So before we start our session, let us quickly recap what we have learned in our previous session. Let us start, children. Do you remember what is the formula to calculate the area of trapezium? Area of trapezium is given by half h into a plus b square units. Now what is the figure shown on your screen, children? Yes, it is a quadrilateral. Now what is the formula to find the area of quadrilateral? That's right, once again. Area of quadrilateral is half d into h1 plus h2. Take a look at this figure shown on your screen, children. What is the figure shown? Yes, it is a rhombus. Now children, what is the formula to find the area of rhombus? It is given by half into d1 into d2 square units. Now children, can you see the images shown on your screen? Yes, a cast ring, 5 rupee coin, and you can see the wheels of a bullock cart and a giant wheel. Now if you notice these outlines of these figures, what do they look like, children? Good. They look like a circle, right? But do you know what is the formula to find the area of the circle? So today, children, in our lesson, area of plane figures, part 2, we are going to learn how to find the area of circles and other related figures. So let us start. By the end of this session, you will learn area of a circle, area of a circular ring, length of arc of a circle, and area of a sector. So first, we are going to find the area of a circle using a graph sheet. Now let us draw a circle with some known radius, children. Now to find the area of the circle, what we are going to do? We are going to make a small square units, as you can see. We are going to make small square units and we'll count the number of square units and we find the approximate area of the circle. But children, we do have another method where we can find the area of this circle accurately. Let us see the other way. So let us take the circle once again. I am going to divide this circle into various parts. You can see here, children, right? So I have divided them into equal parts, and these are called sectors. Okay, children. Now I am placing the sectors as shown on your screen, children. You can notice that. Okay, the length is half of the circumference of the circle. Got it, children? And this part which is shown on your screen is the radius of the circle. Now let us divide this circle into more number of sectors, children. You can see there, right? Now we have divided into more sectors. Now again let us rearrange these sectors as shown on your screen, children. Yes. Now let's see what happens when we join them. Yes, we do get some plane figure, right? Now what I am going to do, children, here I am going to cut a small part of it and place it at the extreme right. Now children, can you just imagine what is the figure formed here, children? The outline figure? Yes, you are right. It is a rectangle. And this part is nothing but half of the circumference of the circle. Right, children? We have already seen. And this part, the shown part, you can see a line is drawn, right? A line segment. That is nothing but the radius of the circle. Now using this concept of rectangle, let us see how we can find the area of a circle, children. Let's see. So we know that area of rectangle is given by length into breadth square units, right, children? But here what is the length, children? Yes, you can see that here the length of the rectangle is half of circumference of circle, and here breadth is nothing but the radius of the circle. This is the breadth, right? This is the radius of the circle. So we have written it as half the circumference of the circle into radius of the circle. Now let us substitute the value or the formula of circumference of circle. It is given by 2 pi r units. and radius is r. Now let us substitute that, children. So we get half of the circumference as half into 2 pi r, and 2 will get cancelled. We get half the circumference of circle as pi r units. So now area of circle will be pi r into r. So r into r gives what, children? Yes, r square. So area of the circle is equal to pi r square units, where r is the radius of the circle and pi is a constant and its value is 22 by 7, or we can take it as 3.14 approximately also, children. Children, I think you understood the derivation of the area of the circle. Okay, children. Now let us apply this concept in solving a problem. The circumference of a circle is 22 centimeters. Find its area. So what is the circumference, children? 22 centimeters. And we know that the circumference of circle is given by 2 pi r units. So I can write 2 pi r is equal to 22 centimeters. Now let us substitute the value of pi here. 2 into 22 by 7 into r is equal to 22. Now what is the value of r, children, here? Yes. Now when we send these two terms to RHS, 22 by 7 will become 7 by 22 and 2 will become 1 by 2. Now if you see, this 22 and 22 will get cancelled. What is left, children, now? That's right, 7 by 2. Okay, children. So now we will find out the area of circle using the formula pi r square units. We got already r value, children, right? Now just substitute it. So that is 22 by 7 into r square, which is 7 by 2 whole square. This can be written as 22 by 7. So 7 by 2 whole square is 7 by 2 into 7 by 2. Now let us cancel 7 in the denominator and 7 in the numerator. Both goes one time. And also 2 goes one time in denominator, whereas in 22 it goes 11 times. Now what is left, children? Yes, 11 into 7, which is 77, divided by, we have only 2. So on dividing this, you get 38.5. Therefore, we can say that the area of the circle is 38.5 square units. I hope you understood the concept, children. Got it? Okay. Now, children, let us learn about the area of a circular path, or we can even say it is area of a ring also. Okay. Now, see the images shown on your screen, children. Yes, it is a dartboard, and this you might have used it for swimming, right? And this is a ring which you generally wear it to your finger, right? Now if you notice the outlines, see, in the first case, in the second case, you can see there are two circles, one inner circle and there is another one outer circle. Here also there is one inner and there is an outer circle. Such type of circles are called concentric circles. So what do you call, children? Concentric circles. Now what are these concentric circles? Circles with same center but different radius are called concentric circles. So these circles, they have same center but they have different radius. So we call them as concentric circles, children. Got it? Now let us find the area of this circular path. What is that? Yes, here you can see this is the path, children, whose area we need to calculate. So that is called as the area of the circular path, or simply area of a ring. Now let us find the formula to find area of circular path. Now let us consider the circular path here, and this is the inner radius and an outer radius. Now let small r represent the inner radius and capital R represents the outer radius. Okay, children. Now what is area of circular path, children? Yes, I can say from this outer circle, that is from this bigger circle, if I remove the smaller circle, I get the area of this circular path, which is given by area of outer circle minus the area of inner circle. Now let us substitute this formula, children, that is area of outer circle and area of inner circle. So area of outer circle is pi r square. So whatever it is, area of circle is pi r square. So outer circle radius is capital R, so we are writing pi capital R square minus area of inner circle. What is the radius of the inner circle? Small r. So we are writing pi small r square. Children, do you find any common factor in these two? That's right. It is pi. Now let us take pi as common, children. What did you get? Capital R square minus small r square. Now this is the formula to find the area of a circular path. So children, the formula to find area of the circular path or ring is given by pi into capital R square minus small r square square units. Okay, children. Or even you can write the same formula as pi into capital R plus small r into capital R minus small r, because if you notice capital R square minus small r square, it is in the form of a square minus b square. So a square minus b square can be written as a plus b into a minus b. Okay, children. So you can use either this formula or this formula. Both represents the same. Okay, children. Now let us see what do you mean by length of arc. Now let us consider the circle. I am considering only a part of the circumference of a circle. Here you can see, children, this is only a part I am considering. Now this part we call it as arc of a circle. Okay, children. And this measurement from A to B, this is called the length of its arc. Okay, children. Now let us draw, mark the center and join OA and OB, children. And this OA and OB are nothing but their radii. That is, OA is radius and OB is radius. Now this shaded region, if you consider, this shaded region is called the sector of a circle. So this only the edge, this is AB, which is curved part, is called as arc of the circle, and this region which is enclosed between the arc and both the radii is called the sector of the circle. Okay, children. So now let us see how to find the length of the arc of a circle. So what is the formula to find the length of arc of a circle? Let's see. Now consider a circle with radius. When we have a complete circle, so what is the angle at the center, children? Yes, 360 degrees. So let us take these values in a tabular form, children. So this is the first figure I am taking. Then the angle subtended at its center by this figure and the length of the arc and relation between angle and length of the arc. That is what I am going to find out, children. So what is the angle, children? Yes, 360 degrees. What is the length of the arc? So here the length of the arc is nothing but the complete circle. So which is 2 pi r, because it is the circumference. So circumference will become its length. Now let us try to find the relationship between. Now can I write this as 360 degrees by 360 degrees into 2 pi r? Because both will get cancelled here and we are left with only 2 pi r. So these two will be same, right? Now let us see the second case, wherein I am going to have only half the circle. What is the half the circle, children? Yes, a semicircle. So here, what is the angle subtended by the semicircle at the center, children? Yes, it is 180 degrees. So since it is semicircle, so what is this arc, children? Yes, this will become half of the circumference. That is half of this 2 pi r, which is pi r. Now I will write this as 180 degrees by 360 degrees into 2 pi r, because 180 degrees by 360, it will come 1 by 2, and here we have 2, both the 2 will get cancelled and we get pi r here, and here also we have pi r. So both are equal. Now let us see another case, children. Now I am going to have only a quarter of a circle, okay, which makes an angle of 90 degrees at the center. So angle is 90 degrees. Now it is half of the previous one, that is previously we have pi r. Now what will be the length of the arc, children? You are right, it is pi r divided by 2. Now what should be the relation? Yes, 90 degrees by 360 into 2 pi r. Why? 90 goes one time and this goes 4 times. Let us see how it is. Okay, so 90 one time and it goes 4 times in 360. I can cancel with 2 here and 2 will get cancelled. You are left with pi r by 2. So this is how we get the same answer, children. Okay. Now let us consider a circle, again an arc subtending an angle at O, right, and r is the radius, and the angle subtended at the center is x degrees, and L is the length of the arc. Then what is the formula, children, to find the length of the arc? Yes, L is equal to x degrees by 360 degrees into 2 pi r. Why like that? So when it is subtending 90 degrees, we took 90 by 360 into 2 pi r. When it is subtending 180 degrees, we took 180 degrees by 360 into 2 pi r. So similarly, when it is subtending x degrees, it should be x degrees by 360 into 2 pi r. So this is the formula to find the length of arc of a circle, x degrees by 360 degrees into 2 pi r. Okay, children. Now let us see about area of sector. Now we have already learned what is a sector, children, right? So the part of a circle bounded by two radii and an arc is called sector. So here if you notice, this is the sector, and here these two are radii and this is the arc, and it is subtending an angle x degrees at the center. So this shaded portion we call it as a sector. Okay, children, and even this portion is also called as a sector, children. Okay, so area of a sector and its angle are in direct proportion. That means suppose if I have 90 degrees, so area will be say something like this. If it is 180 degrees, area will be like this, right? So as the angle at the center increases, area of the sector also increases. When the angle decreases, area also decreases. So we say they are in direct proportion. So I can write area of a sector is to area of a circle is equal to x degrees is to 360 degrees. Now let us see how to find the area of a sector. So we know that A is to B is written as A by B. So area of a sector divided by area of circle is equal to x degrees by 360 degrees. Now what we will do, children? We will send this area of a circle to right hand side. Let's see what do we get. So area of a sector is equal to x by 360 degrees as it is, no change, into, since it is in denominator, when we send it to right hand side, it becomes numerator. So into area of a circle. Now what is the formula to find area of a circle? Pi r square. Now let us substitute that value. So we get x degrees by 360 degrees into pi r square. So this is the formula to find the area of sector, that is x degrees by 360 degrees into pi r square square units. Now let us apply these concepts that we have learned in solving few problems. Let us start with our first problem. Find the area of a circle inscribed in a square of side 14 centimeters. Let us start with the solution. So here you can notice a circle is inscribed in a square. That means a square is there whose side is 14 centimeters. Inside that there is a circle touching all sides of a square. Now what we need to find, children? We need to find the area of the circle. Okay, children. So to find area of a circle, what is needed? You need radius. So that means first we need to calculate the radius of the circle. Okay, children. Let us see how to calculate. So here, since the side is 14 centimeters, so this 14 centimeters become the diameter of the circle. So diameter of a circle is 14. Then what is radius, children? Yes, radius will be half of the diameter. So half of 14 is how much? 7. So radius of the circle is 7 centimeters. And we know that area of a circle is given by pi r square square units. Now let us substitute the values of pi and r. So pi is 22 by 7 into r square. R square means r into r. And here r value is 7. So we get 7 into 7. Now 7 goes in 7 one time in denominator part, and in numerator also it goes one time. Now what is left, children? Yes, 22 into 7. On multiplying this, we get 154. That means the area of the circle inscribed in the square is 154 square units. I hope you understood the problem clearly, children. Now let us move on to our next problem. Calculate the area of shaded part of the figure given below. Let us start with the solution. Okay, children. So here you see that this is a shaded region. So area of shaded region is given by area of rectangle AGJF plus area of rectangle HCDI plus the area of semicircular ring, that is this part, this semicircular part, plus area of the other semicircular part. So that is here you can notice. So these four areas will find and just add them up. Okay, children. Now let us see how to find. So area of rectangle, length into breadth, So it is AF into JF. So we get 22 into 3.5 because AF is 22 and this width is 3.5. So 22 into 3.5. On multiplying it, we get 77 square meters. Similarly, area of rectangle HCDI is CD into DI. Let us substitute the values again. They are also same. That is 22 into 3.5. We get 77 square meters. Now let us find the area of the semicircular ring. Okay, that is this part. So that is given by pi into r square minus r square. So that is 22 by 7 into capital R is 10.5 whole square because the diameter is 21. So its radius will be 10.5. So 10.5 whole square minus, here the diameter is 14. What is the radius, children? 7. So 7 square. Now let us substitute the values of 10 square and 7 square as shown on your screen. On subtracting them, you get 22 by 7 into 61.25. Now 7 goes in 7 one time, whereas in 61.25 it goes 8.75 times. Let us multiply these two, 22 into 8.75. We get 192.5. So we got 192.5 as the area of one semicircular ring. So therefore the other semicircular ring also has the same area, 192.5 square meters. Therefore the area of the shaded region is 77 plus 192.5 plus 192.5. So therefore we can say the area of the shaded region is 539 square meters. Let us move on to our next problem, children. The area of an equilateral triangle is 49 root 3 centimeter square. Taking each angular point as center, a circle is described with radius equal to half the length of the side of the triangle. Find the area of the portion in the triangle not included in the circles. Let us start with the solution. So children, there is an equilateral triangle. So let us first draw the equilateral triangle and taking each angular point as center. Now this point and these 3 points as center, we are going to draw a circle. Okay children, and what is the radius of that circle, children? That is equal to half the length of the side of the triangle. So this is the length, half of this length. So let us draw 3 circles as shown. Yes, we are drawing 3 circles, children. Now which area we need to calculate, children? That should not be included in the circle. That means if you notice this shaded region, this area we have to calculate. Now let us see how to find the area of this shaded region, children. So given area of equilateral triangle is 49 root 3 centimeters square. Let us assume the side of equilateral triangle be A units. So all the sides are equal, so it is A and A. Okay children. Now area of equilateral triangle is given by root 3 by 4 A square. This is the formula to find area of equilateral triangle. Already it is given that area is 49 root 3. So both must be same. So we have root 3 by 4 A square equal to 49 root 3. Now let us find the value of A square, children, here. So that means we are going to send this root 3 by 4 to right hand side. We have already seen in the previous case. So what will happen? So 4 will go to the numerator and root 3 comes to the denominator. So it is 49 root 3 into 4 by root 3. Can we cancel here anything, children? Yes. If you notice, both the root 3's will get cancelled. We are left with A square equal to 49 into 4, which is 196. Now what is the value of A, children? Yes, A is equal to square root of 196 and the square root of 196 is 14. Therefore we got the length of the side of an equilateral triangle is 14 centimeters. Okay children. Now here if you notice, these angles are all equal, right? So what is the angle, children, here? 60 degrees each, because it is an equilateral triangle, all the angles are equal and each angle will be 60 degrees. Okay children. Now what is the radius of the circle, children, here? It is half of the side of the triangle and we got the side as 14. So half into 14 we get 7 centimeters. So we got radius as 7 centimeters. If you notice, children, this part is a sector and again this part is another sector. This part is another sector and all the sectors have same radius and angle subtended at the centers is also same. That means if I find area of this one sector, that means it will be same for the other two sectors also. Okay, children. Now let us find out the area of one sector. What is the area of sector formula, children? X degrees by 360 degrees into pi r square square units. Now let us substitute the values and simplify. Here x, that is 60 degrees, so 60 by 360 into pi value is 22 by 7 into r square, r is 7, so I get 7 square. So 60 goes in 60 one time and in 360 it goes 6 times, so I got 1 by 6, 22 by 7, 7 square, I am writing it as 7 into 7. Now further simplification, here 7 goes in 7 one time, again in denominator 7 goes in 7 one time. So we are left with how much, children, now? Yes. So again I can cancel 22 with 2 11 times and 6 it goes 3 times. We are left with 11 into 7, 77 by 3 square centimeters. So this is the area of one sector. So what is the area of shaded portion, children? Yes, it is area of equilateral triangle minus 3 into area of sector. Now let us substitute the values. So area of equilateral triangle is 49 root 3 minus 3 into, we got area of sector as 77 by 3. Now these 3 will get cancelled, you are left with 77 and the value of root 3 is 1.732. So let us multiply 49 with 1.732. You get 84.87 approximately minus 77. On subtracting this, you get 7.87 square centimeters. Therefore, I can say that the area of the shaded portion is 7.87 square centimeters. Now, before we end our session, let us quickly recap what we have learnt in this session. Area of circle is given by pi r square square units. Circumference of circle is given by 2 pi r units. Area of circular path or area of ring is given by pi into r square, that is capital R square minus small r square, or pi into capital R plus small r into capital R minus small r, where capital R is the outer radius and small r is the inner radius. Length of arc L is given by x degrees by 360 degrees into 2 pi r units. Area of sector is given by x degrees by 360 degrees into pi r square square units. And area of a sector A is equal to LR by 2 square units, where L is length of arc and R is the radius of the sector or circle. Before we end again, I want you to do some problems based on the concept that you have learnt in this session and show the same to your subject teacher. Okay, children, let us see those problems now. A horse is placed for grazing inside a rectangular field 63 meter by 42 meters and is tethered to one corner by a rope 14 meter long. How much area can it graze? A wire is bent into the form of a square of side 24.2 centimeters. The wire is straightened and bent into the form of a circle. What will be the area of the circle so formed? The next problem is 4 equal circles, each of radius 14 centimeters, touch one another. Find the area between them. Find the area of the shaded region if ABCD is a square of side 21 centimeter and AXD and BXC are semicircles. Okay, children. So solve these problems and show to your teacher. I hope you have learnt all these concepts very much clearly. Okay, children. So we'll meet in our next digital class. Until then, goodbye and take care.